Hi guys, so I'm going to explain to you what you need in order for an E1 reaction to occur. And first of all, it's important to know that the E1 is a deprotonation of the carbon adjacent to the carbocation. So first of all, the E1 reaction favors a tertiary leaving group and stable carbocations. Then, if we're talking about reactivity, the tertiary carbon is the most reactive, followed by the secondary carbon, then the primary carbon, and finally a methyl group. This is due to hyperconjugation, which allows nearby CC bonds or CH bonds to interact with the p orbital of the carbon. This is going to lower the energy state of the electrons and then stabilize the whole molecule. And the base can be weak in an E1 reaction, and as a weak base this favors an E2 reaction. It's always going to favor an E1 reaction.
To add on, in order for an E1 reaction to occur, it requires heat. Also, the reaction is favorable in a protic polar solvent. That means that the polar protic solvents have an easier time stabilizing a carbocation. Also, the E1 reaction needs to be unimolecular because the limiting step is the formation of the carbocation. That's the slowest step. And the E1 reaction depends only on the substrate. Also, the rate depends on the formation of carbocation, and a methanide and a hydride shifts are possible during the E1 reaction.
So for E1 reaction, this reaction involves two steps that is following each other. So the first one is when the leaving groups leave, so the departure of the leaving group. Then following that, there's the deprotonation of the carbon that's next to the carbocation, so the one that's adjacent to that. The proton that is leaving is removed by a weak base. By looking at double bonds in this reaction, the double bond that's the most favored is the one that's the most substituted. And in this reaction, heat is favored. The rate limiting step of the E1 reaction is unimolecular, meaning it's only determined through one molecule. And finally, carbocations are ions that are polar. So if we follow the rules of like dissolve like, in E1 reaction, the solvent that is going to be used is polar protic solvent.
Hi! Time-wise, we weren't able to fit that in class today. We're P team. We're talking about elimination 1, so unimolecular elimination. And here you can see that this was the molecule that was given by Cash in our practice problem, and this is supposed to be the result. So I'll try to, you guys gonna assist me on how I'm gonna arrive to this answer, okay? So I have this cyclopentane here with this Cl that acts like a leaving group. Okay, so here we can see first of all that H2O is a polar protic solvent, and this is heat. This should sound to you as E1 because it's the perfect conditions in which E1 will flourish. Here, Cl leaves. It will create a carbocation, which is polar. It's an ion, like dissolves like. Polar product, perfect. Then, we will assist to a ring extension. It is not to be miscategorized with hydride shift, since it's an alkyl shift. It is the ring that extends itself to the carbocation. So as you can see here, this part of the ring will come like somewhat like this, and then this part will form a cyclohexene like this. Okay, and then our water, the polar product solvent, will react to the carbon to the hydrogen adjacent to the leaving group. In this case, it's this hydrogen here. It will form a positive charge that will, when doing its stabilization, form a double ring here, a double bond here. And this is how you get from here to there.